Assuming you have already installed the Shiny app through Docker image, or you are accessing it through the web tool, whichever menu you are adopting to, you will be facing this landing page, and this page is giving an overview and instruction about how to follow the steps and conduct analysis using the app, which are just essentially what I will be talking about in this video. And if you have internet access, you may visit our website for a detailed documentation on method and visualizations and etc. So first, before using the app, please make sure that you have already obtained the data, the DHS data that will be used for the analysis. And if you are using the Docker image, you have downloaded the WHO shapefile following the guideline provided. And in this page, you can use this click here to collapse or expand each modules, the instruction for each modules as you following through the steps. And this panel, bottom hyperlinks will help you to link to different panels, which are more convenient if you are going through the steps. And each modules are structured similarly, so please try those out. And then I'm going to just show an example of using the app for conducting analysis. So under the first, we want to specify the country specific information. And if you are using the web tool, the shapefiles are internally loaded, so you don't need to do this step. But for the Docker image version, you need to manually upload the shapefiles, which have been downloaded. Now I'm just showing an example for Burkina Faso. And so these are the shapefiles that I downloaded. And can select the country and select the survey year that you are interested in conducting analysis for. Here you can have a sense of the geographical boundaries of the country you have selected. You can click here to check different levels and see whether the regions are aligned with your analysis needs. And of course, we want to select an indicator for the analysis. The indicators in our app are organized according to where they appear in the DHS chapters. And for this demo, I will just use the family planning indicator, the use of any modern contraceptive usage. And for the detailed definition of this indicator, you can click here, which will lead to the toolkit. And these are the full definition specified through the DHS standard dictionary, where you can see the unique identifier of this indicator and the label, full definition, and which chapter it comes from, and the denominators. For some indicators which the time window can vary, we use the 5-year period preceding the survey. And if the indicator can be stratified by age groups, we default to the total population if not otherwise specified. And here you can also check out the whole list of indicators that we support in this Shiny app. And for the they are just we want to emphasize that this is only a subset of the indicators defined by DHS, and we are including more indicators along the way. So let's go back to the country specification. So after checking, selecting all the metadata and make sure that the admin levels are aligned with your analysis need, we are ready to proceed to data upload. Assuming you have already obtained the data, you can upload the zip file. And for each different indicator, the needed read code are different. And in that case, our program will locate the correct recode for this indicator and parse it through the zip file, and then preparing for the analysis dataset. This step might take maybe 1 minute or two if the dataset is big. And within this step, we are also providing the GPS data so that the locations of each cluster will be matched, and the individual's location will also be available through this process. And we can see that if the checklist are all green, means that the data set is successfully prepared. And we can here see the map or the spatial distribution of clusters. You can see that some regions have low number of clusters, which means the data are more sparse. And for some regions, like the capital, there are more clusters available, which is just more data. And if we go down to finer spatial level, you can see that some regions does not have data at all, and some regions are still having a lot of data. And this we need to take into consideration when we fit fine scale spatial models, because if the data are too sparse, the result might be unreliable, and the method like the red estimate won't produce any result for the region without any cluster. And here we can also have a preview of the data. This column value will indicate the binary value for that for the indicator you are choosing. And you can download this raw file as CSV if you click here. And yeah, that's at this step you have successfully uploaded data. And because the coding of indicators might be country or service specific, so we cannot guarantee that all the indicator you selected work for the country you are using. And but we will have prepared error messages if that happens, and please report those to us so that we can customize the coding for that survey and make it work. Yeah, and then before we head to actual model fitting, we want to check whether this indicator is consistent with the DHS final report, and we can achieve that using the verification panel. And as I mentioned, that the coding for different indicators might be country or service specific, and especially for DHS 8 service, for some indicators that we include in the app, the national estimate might not match exactly with the DHS final report, and if there are some huge discrepancies, we definitely do not recommend proceed. And yeah, you can report this issue to us so that we can modify the coding. And here we can see that the national estimate for this indicator we have chosen for this specific survey is 27.94, and the DHS final report estimate, which we obtained through DHS API, is 27.9, which are a match exactly. So we are confident that this indicator is reliable, and we can proceed to model fitting. Going back to the model fitting page, and before we actually conduct analysis, we highly recommend that you digest the material that John has presented, and also a material that is on the website for the method of these models. And if you are already familiar with those, we can start analysis. So the first step is to check the sparsity of the data. So as we have learned that if the data are too sparse, then the model fitting can be problematic. And in the case of Burkina Faso, I think most of the models passed, all of the models passed the data sparsity check. And in some other countries, when there are more admin 2 regions, this data sparsity check might throw out some warnings or error messages, indicating that some fitting for certain models are highly unrecommended. So we should just be careful about that. And once the data sparsity check has been done, we can proceed with model fitting, and we can just run model that passed check, or we can run all models since and if they are some other service, when the data are sparse, we sometimes give recommendations, like you can click here to see that some orange warnings saying that we do not recommend fitting the model, but theoretically it's possible. It probably won't throw out error, but just the interpretation of the result can be tricky. And in that case, you can click run all models. That will another button showing up. And in this case, since we have plenty of data, all the models are fitted successfully and we'll be ready to check the results. And under result visualization, we have different tools that can help you to see the spatial distribution and also comparing estimates. The most straightforward one is the prevalence map, and here we can select the model that we have just fitted, like the direct estimate area level model or unit level model, and also select a mean level for that model. And here we can plot the mean or the point estimate, and you can use the hover effect to see the uncertainties and also some other measures like coefficient of variation. But if you want to actually plot the other statistics, you can use the drop-down menu. And yeah, here is the plot for the coefficient of variation. You can see that this region, the data are more sparse, so there's a higher coefficient of variation. And for the capital, the data are more, there are more data, so the coefficient of variation is smaller. And we can check out at mean 2 level, can see that a lot of regions just do not have data at all. So that is, the estimate are just not reliable. But if we go to like unit level model, we would have some estimate, but since they are, data are sparse and we are borrowing information from the neighboring regions, for those regions that originally does not have any data, although here unit level model gives some estimate, they are of higher certainty. And another statistic that is very interesting to look at, especially for making some inference, is the existence probability map, which at the default value shows the probability that each region is higher than the estimate for each region is higher than the national average, which is 0.28. And we can see that for the region on this part, the estimate is probably, the prevalence is probably higher, so that we have a higher probability that the prevalence in that region exceeds the national average. And for the region in this part, it's lower, meaning that the estimate is probably lower than the national average, or the prevalence is lower than the national average. And then we can also compare plots. We can either we can compare maps. We can either plot different statistics from the same model against each other. Like in this case, we just plot all 4 statistics that we just talked about for this direct estimate at a mean 1 level together, so that we can better see the, for example, the point estimate and the certainties measures side by side. And we can also compare estimate across models using the from the same statistics. For example, we can compare the mean through some models, and by checking all the boxes and clicking generate plot, the plot will show up, and we can see that at the mean 2 level, there are more heterogeneity in the regions, and the direct estimate have, for a lot of regions, they do not produce reliable uncertainty measures, but the unit level and Saeforhealth model produce some, more reliable estimates, and they are, actually some effective spatial smoothing, like the surfaces are smoother than the direct estimates. And then we can use scatter plots to compare the estimate from different models at the same level. So for example, we can compare at the mean 2 level direct estimate versus unilevel estimate. And in this plot, we can see a trend of smoothing. Like the x-axis plots the direct estimates for those regions, over 100 regions, and the y-axis are the unilevel model estimates. And we can see that for regions, for all the regions, the estimates are pulling towards the overall mean, which is a clear effect of spatial smoothing, because we are just pulling information across regions so that they are, they will be look more similar. And these red regions indicate that the regions originally does not have any direct estimate or does not have any data. And then we also have the ridge plot, which is a powerful tool if we want to actually see the full distribution of the estimates. And so that is very important for inference, because when comparing point estimate, two regions might be quite different, but when we consider the uncertainties or showing the distribution of the estimate, they actually overlap a lot, indicating that the two regions estimate are not actually that different. And here we can select the model and level, and for example, we can plot the admin 2 level estimates from the unilevel model, and since there are over 100 regions, oh sorry, probably I think it's 70 regions, yeah, we should we can just pick the top ones. For example, we can plot the regions with highest estimate and the regions with lowest estimate. And so in this plot, it's clearly showing that there are definitely some heterogeneities across the regions. I mean, for the regions with lower estimate and high estimate, they are quite different. But for the regions having the low estimates, they are not that different. And that's a similar story for regions have high estimates. And oh yeah, you can also download those as PDF, these plots. And yeah, that's similar thing for the maps, but you have to use the non-interactive versions, so you can download them as PDF if you want to use for reporting or some other product. And in the end, I want to show we can also export the result as CSV files, like the statistics for a model. And for example, admin 1 unilevel model, we can report all the statistics in a tabulated format, and that can be used for different result interpretation and the presentation. Yeah. I think that's pretty much about the app, and we would love to hear your feedback. Thanks.